All right, in this question, we're starting to get to the next level of titration calculations when we're searching for pH. Now, this is an example where we have a strong acid, nitric, and a strong base, lithium hydroxide, and we're having to figure out what is left. Do we use up all the acid and have base left over, or do we use up all the base and have acid left over? Whichever is left over, if there's neither left over, we're at pH 7. If there's one of them left over, then since they're strong, whatever concentration is left of either the acid or the base is going to be the concentration of H plus or OH minus, which can tell us pH or POH. So let's take a look. At first glance, I have 25 milliliters in my problem of 0.15 molar nitric. And I have 40 milliliters of 0.25 molar lithium hydroxide. So I have higher concentration and higher volume of lithium hydroxide. So my first guess is I'm going to have excess OH minus. I'll use that excess, solve for POH, and then convert to pH. Okay, so let's do some calculations. So titrations are done with moles. So we have to figure out moles. And then when we have the excess moles, we'll have to divide that by our total new volume. So let's find moles of HNO3. So we have 0.150 moles per liter. And then I'm going to multiply it by liters, cancel it out, and get moles. So I have to be in liters, so 25 milliliters divided by 1,000. So 0.15 times 0.025 tells me how many moles of nitric acid I have. So let's do that calculation. 0.15 times 0.025, I get 0.00375. Now let's look at our lithium hydroxide. We have 0.250 moles per liter times 0.040 liters. So 0.25 times 0.04 equals 0.01 moles of OH minus. So we have more OH minus, so we need to figure out exactly how much more we have. So we're going to subtract 0.100 minus 0.00375, because the OH minus will react with H plus to form water. But once we use it all up, we're left with excess OH minus. So how much excess? We got 0.01 minus 0.00375, and we get 0.00625 moles of OH minus left. Now, remember, POH is equal to negative log of OH minus concentration, but it's concentration, not moles. So we got to take this number and divide by our new volume, which is 40 plus 25. So 65 milliliters, so 0.065 liters. So 0.0625 divided by 0.065 equals 0.096. So let's do the negative log of that number. So negative log of 0.096 and I get 1 point, so POH equals 1.02. pH is 14 minus, and I get 12.98. It looks like 3 sig figs, so I would go with 13.0 as my pH. And there we go. Okay, so it's all about the moles. Got to figure out what's excess, the strong acid or the strong base, and then it's a direct correlation of H plus or OH minus. If we had a weak acid and we had excess weak acid, we would have to use the Ka and use ice tables like we have in the past. So they can get fairly complex. We'll look at some of those more, but this is a beginning of titration calculations.